configurations of atoms. Now, you remember when you were in second year and you were drawing out atoms, structures of atoms, and you might be asked to draw out sodium, say for instance. Sodium has 11 electrons, so you would have put 2 electrons in the first shell, you'd have put 8 electrons in the second shell, and then you would have said 1 in the third shell. So then you would have written down Na equals 2,8,1. So remember doing that. Now, we need to divide up the energy levels, or the shells as you would have called them, into sub-levels when you're writing for Leaving Cert. So this picture here, it's important that you familiarise yourself with this. So for instance, you can see here, you've got the shells here going up along the left, okay? So we would have called them shells in second year. You now need to maybe use the term energy level. So this is energy level number 1 and number 2, number 3 and number 4. Now, you would have learned in junior cert that you could have put 2 electrons into the first shell, we would have called it. You can put 8 electrons into the second shell, and you would have been told in second year that you could have put 8 into the third shell. That's technically not correct, okay? So we'll check in a second now, and we'll see how many electrons can we put into the third shell. Now, you need to learn, for the purpose of Leaving Cert, is that the main energy levels are subdivided into what are called sub-levels, all right? The first main energy level doesn't have a sub-level, that's just 1s, okay? Now, the names of the sub-levels are important too. So they're S, P, D, and F, okay? So you just have 1s there. The second main energy level is subdivided into 2 sub-levels, 2s and 2p, okay? Now, 2s can hold 2 electrons, and the 2p can hold 6, so 2 and 6 is 8. That's where you get the 8 electrons in the second main energy level. 2 into 2s, and you can put 6 electrons into 2p sub-level. N equals 3, look at the blue lines, it's made up of 3 sub-levels. 3s, 3p, and 3d. Now, into the s sub-level, you can put 2 electrons. Into the p sub-level, you can put 6, look, and into the d sub-level, you can put 10. So how many electrons can you put in total into the third main energy level? 2, 6, and 10. So it's actually 18 electrons. And then the fourth main energy level up here is divided up into 4 sub-levels, 4s, 4p, 4d, and 4f. Now, do you notice there, look, that the purple 4s sub-level line is below the 3d? That's because it's going in terms of energy. So the 4s sub-level has lower energy than the 3d sub-level. So in a minute now, when you're putting electrons into sub-levels, you must fill the 4s first before 3d. Now, Aufbau's principle states that when building up electron configurations of atoms in their ground state, then you must put the electrons into the lowest available energy level. So let's just clarify for 1 second now before I do an example with you. You've got 4 main energy levels. N equals 1, N equals 2, N equals 3, N equals 4. The first main energy level, just the 1s. It's called 1s, and you can put 2 electrons in there. The second main energy level is subdivided into 2 sub-levels, 2s and 2p. You can put 2 electrons into the 2s sub-level, 6 electrons into the 2p sub-level. So in total there, you can put 8 electrons into the second main energy level. The third main energy level is divided into 1, 2, 3 sub-levels. What do you call them? 3, because it's the third main energy level. 3s, 3p, and 3d. Now, how many electrons can you put into the 3s? 2. Like you can put in 2 into 2s and 2 electrons into 1s. You can put 2 into 3s. You can put 6 electrons into the 3p sub-level. And you can actually put 10 electrons into the 3d sub-level. Okay? So when you add them up then, how many electrons can you put into the third main energy level? 2 and 6 is 8 and 10. 18 electrons in total into the third main energy level. Now, the fourth main energy level is made up of 4 sub-levels, but I am drawing through the 4s there lower than 3d. Now, you can actually disregard the other 3 sub-levels in the fourth main energy level because you just go as far as 3d. So you must familiarise yourself with that picture now first, okay? Now, let's try and write the electron configuration for something like sodium, like I mentioned earlier. Remember at the beginning of the video, I said to you that in second year, if you were drawing out the atom of sodium, you'd notice that it has 11 electrons, and then you'd be writing 2, 8, 1, okay? Now, that's good enough for junior cert, but for leaving cert, you have to divide up the sub-levels. So if I was writing the electron configuration, where the electrons are in the energy levels inside an atom for sodium, I would be writing, right, 1s2. So 2 here stands for the number of electrons. The next sub-level is 2s. That can have 2 electrons. And then you're going to 2p. Now, stop for a second. 2 and 2 is 4. So I will put the 6 in there to make 10. Okay, now I have 10 electrons put in. I need to put in 11 electrons. So now I'm going to say, what would be my next lowest available energy level? 3s. But I'm only putting 1 electron in there, because now I have 11 electrons filled. So 2 and 2 is 4 and 6 is 10 and 2. So that's the electron configuration for sodium. Now what about if I did something like calcium? Okay, so with calcium, with calcium there, you'd look at your periodic table. Calcium has 20 electrons, okay? So what would I write for that? Well, you start with the lowest available energy level, which is 1s, 2, comma, 2s2. Next one is 2p. I can put 6 into 2p. Then I have to go to 3s. I can put 2 into 3s. 3p is next. I can put 6 electrons into the 3p sublevel. Next is 4s. So count up now. How many electrons have I put in so far? 2 and 2 is 4 and 6 is 10, 12, 18. And I can put 2 electrons into the 4s sub-level. So double check now that you have the right number of electrons. That's the electron configuration for calcium. Okay? Now, what I want you to do now is I want you to write the electron configuration for oxygen. And oxygen's atomic number is 8, so you'd have to be filling in 8 electrons. Magnesium, 12 electrons. And iron has 26 electrons, okay? So I want you to write the electron configuration for those 3 atoms and email me the configuration.